doing. We want that to be microphone. Okay. Okay, that should be audio working. First glitch of the evening. And also my desktop audio here. Set to that. Okay, we're good. Try and make a beep. Ding. Sounds good. Right, nobody watching at the moment, but never mind. Let's press on. Okey-doke. Okay, first thing is here we see the out-of-focus image that I took yesterday. The Observatory was just unable to focus correctly. So first thing we're going to do is bring it online. And there she is unparking. Okie dokie. And we will open the shutter. Okay. Now it's not fully dark outside, but it should be dark enough to find some stars to focus on, and by the time we faff about, it should be well dark enough for what we need. Alright, imager. Need to power up the imager and cool the camera. Cooler should be able to go down to -35. It's currently 31. Wow, it's warm in there. Hopefully with the shutter open that will cool down a bit. Now with an ambient temperature of 31, the camera may not be able to reach the target temperature of -35 because it can only cool 60 below ambient. So hopefully it will cool down really quickly in there now that the shutter's open. There's a bright star there, look, just right in front of the telescope. Oh, that's handy. Let's fade to, there we go. Can you see that? Just there. at the end of the mouse. Okay. What we need to do is to remote into the observatory. But before we could do that, I'm going to do as much as I can remotely. For various reasons, the observatory computer doesn't like me remoting in, so I have to be a bit careful. And we can use one of the utility tasks in here to... Oh no, we're not focused, are we? Okay, so let's use the bright star finder. Okay, so this is running the script and it will prompt us for a filter in a minute. There we go, we use clear filter, which is filter 0. So what this script does behind the scenes, it looks in a database into a Stellar catalogue, and we are using the Atlas reference catalogue. It will find a star between a certain range of magnitudes that hasn't got anything confusing nearby it, and it will slew to that star. And then it will take an image and plate solve the image and see if the telescope's where it thinks the telescope should be. And if it is, all well and good. If it's not, it will sync the telescope to the actual position and then move to the star. Now, this may not work well because we can't focus. So I'm expecting that the script may fail, but it should get us close to a usable focus star. So okay. Now the telescope didn't move. I don't know if that's because we were nearly on the star already, but or maybe the telescope's not working. It's having a tendency to overheat, and then the drive system freezes and I can't move the telescope. So this may be the shortest live stream in a while, depending on... No, because we saw it unpark, right? So the telescope is working, but okay, so we found 29 image stars in the image, but we couldn't match, so we should probably have found a lot more stars, but they're going to be all out of focus. Okay, we might remote into the observatory at this point and see what's happening. So the observatory in the computer is about 12 years old. It's one I built professionally. I built a whole bunch of computers for customers, and this was one of the ones I built and I kept myself instead of selling. And I like to think I did a pretty good job, and it's been going for 12 years, and Fern's been using it for a few of those years, and I was using it before that, and now it's in the observatory, but it is struggling a bit. It's not got enough memory really, and it's just real slow. So okay, so let's have a look in Maxim. Okay, so as you can see, we do have out of focus stars. Right, so let's look at the Expose tab. Where's ACP? I think ACP is trying to do an all sky plate solution, which will probably fail, but that does tie it up for like 10 minutes. Sometimes it's quicker. So the weather is good. I actually have 3 separate screens going here, and you're only seeing one of the screens. So I've got loads of other information I can look at, and I'm looking at the weather right now. So the nearest storm distance is 203 miles, and we have rain expected in about 2,000 minutes. Alexa, what's 2,000 divided by 60?
2,000 divided by 60 is approximately 33.3333. Did that answer your question?
Yes, thank you.
Thanks for your feedback.
Okay, so that's about 30 hours, so it won't be raining anytime soon. And the cloud cover is currently 0.01, so that's 1% cloud cover, which is very low. The humidity is currently 66%, wind speed 8 miles per hour, well that might be kilometres actually. Visibility 10 miles plus, and we are 6.6 degrees above the dew point, so there shouldn't be any dew at the moment. Okay, what's ACP doing? Come on, ACP. Are you still? I'm pretty certain it's doing a all sky plate solution using a cloud-based plate solver. And when that happens, it just freezes, which is Bob, if you watch this live stream, thou shalt not block the UI thread ever for any reason, period. And ACP has loads of bugs in it because you do. Okay, so while we're waiting for ACP to sort itself out, let's go. Oh, I'm actually completely frozen out now. That's annoying. there's nothing we can do but wait at this point. I could terminate the task, but yeah, there's no point in that. So this will probably provoke a crash in ACP if I do this, but let's have a look. I don't think we need the link open. Okay, I'm just not able to control the computer in any way at the moment. Can quit from there. We go. Okay, so I've got some semblance of control back. I won't need the scheduler. This is a bit weird. Exit ACP scheduler. It's like, oh no, I can't. Okay, not good. Can I not get rid of this thing? Okay, let's kill ACP. Go away, ACP. Okay. I've never seen it do that before, but that was the problem. So, let's get the observatory screen up. We are connected to the telescope already. Let's connect to the focuser. Yeah, thanks, scheduler. We know there's a problem. Scheduler relies on ACP, and because I've killed ACP's task, the scheduler is now completely freaking out. There we go, I've terminated that as well. Okay, so we're connected to the focuser and we're connected to the telescope, so we should be able to see in here our current coordinates, and the alt-azimuth is changing, which means we are tracking, and that's confirmed by the tracking bar down here. I'm going to move this window off to the other screen. And we will get the expose controls up here. And we will take a fine star exposure, which is just a 1 second exposure at binning 4. So it's just maximum number of photons gathered in the shortest time possible. and when that result comes up, this is it, we can pick a, okay, there we go, that's interesting. I have to connect to the dome. I think the dome's closed. Okay, so let's connect to the dome, and then if we switch to the other window here, we can set Dome Tracks Telescope, and that will adjust itself. Okay, and then we'll try that exposure again. Okay, that's the same. We'll just do that raw and not with an RBI pre-flash. And I think there's a star there. So, subframe on, based on the mouse drag box, and put that into continuous mode. Binning 1. Let's do a 2-second exposure, 3-second exposure. I'd like a brighter star really, but first things first, we need to be near focus. Okay, we can zoom that a bit. And there's our star, and there's a couple more here which will become clearer when we're near focus. And I'm going to go over to the other screen here and just manually, right, we're currently on focus position 94,300, and I'm going to run that into position 79,200, which is the last position I set manually. So we're just going to hit move to, and you should see this start to change. There we go. And then that's my best guess at where we need to be, and if anything maybe a bit closer to 0. So we can see what happens to this image, if anything. And it has improved. Okay, so it has improved. So I'm going to just get up a statistics window here, so we can display large statistics. Where is it? There it is. Okay, and this will tell us what's happening in real time to our image. We're not getting an FWHM measurement at the moment. We're getting half flux density of 3. I believe that's probably in error. So I'm going to run this down to 30,000. Which is getting awfully close to 0. Okay, there it goes. The focus is moving in. So we should see the results of that shortly. Okay, that looks almost in focus, doesn't it? So we go down to 20,000. Where's my large statistics gone? Oh, look at those. Now I've probably overshot at this point. Oh, the large statistics window has disappeared. I've never seen that happen. There it is. Oh, it is actually a separate window. So if we put it here. Okay, now we're getting an FWHM reading 7.71, which is probably a bit big, but that might be enough to get a plate solution. So if we stop the imaging, and now we're going to take a plate solution, a pointing exposure image for 8 seconds at binning 4. And we'll display that. Okay, that's looking better, isn't it? Apart from the vignetting, but never mind that. We can try to plate solve that with pinpoint astrometry. Go ahead. I'm expecting the pointing to be quite a bit off because of issues I've had recently, so it may take it a while to solve this. Tell you what, I've just noticed something here. We'll stop that. I need to set the pixel scale from the fit scale, which is that's much closer to reality, and we'll try that again. And if it doesn't work, we'll use the okay, we've got a solution. Good. So now what we can do is we can go to the telescope tab over on the other screen. Good. We go to the telescope tab and we can sync the telescope to the solved position. Okay. And that's updated. And I think that's as far as I want to go there, so I'm going to just disconnect everything in here at this point, and I'm going to run ACP and let that connect to everything. Let's close that. Okay, and I don't know if you can hear that clicking sound every few seconds. That will be ACP servicing remote web requests. Okay, let's go back to the Maxim tab. Okay, so if we can move to ACP so we can see what it's doing. Come on, ACP. Oh. Yep, that's the wrong button. There we go, there's ACP. Right, now it's turned off telescope tracking, so what we can do now is okay, we can now use the find bright star script. Find bright star luminance filter. And we can run that script. Now ACP should run through that automated sequence again where it finds a suitable star in the catalogue. It will move to it, take a picture, plate solve the picture and adjust as necessary to make sure it's where we think it should be. It's currently searching 15-degree section of sky for suitable stars. And Atlas RefCat is a big catalogue, so it does take a while to do this, especially on my steam-powered 12-year-old computer. So it says here we're looking for stars between magnitude 5 and 7, and the significance of that is that it's a star that's big enough to image quickly but not too quickly, so you probably want a 1 to 2 second exposure to average out the seeing a little bit. So you don't want an exposure any shorter than a second. 1 to 2 second exposure is pretty good for focusing. And that's the magnitude range that produces usable stars on this particular observatory, so it's all good. Boy, does it take a long time though. Nearest storm distance is down to 77 miles. There may be weather coming. Although no rain is expected, so I don't know what kind of storm that would be. Maybe just clouds. Okay, we good ACP? Start slew to bright star. Okay, so yeah, the telescope's moving. Oh look, RA went to 0. Well, that must have been a bug. Starting exposure, so here's maxim exposing. 8 seconds, and we should see the image appear here. In about another second. There we go. Oh, perfect, and there's our bright star. Okay, so ACP will now plate solve that image, which hopefully will go a lot quicker, and it did. No. Okay, solved. Pointing error is 2 arc minutes, which is pretty damn close, and it will now adjust the telescope position so that that star's in the centre, and then track is flashing, which means that ACP is about to turn the tracking off, so I'm going to click that to force it to continue tracking, and then we'll just do another we'll just do a fine star exposure with max in, just to see how close we got. And look at that, it's right on the crosshairs. Well done ACP, excellent job. And now what we can do is what's our FWHM is 2.2, so we are actually pretty close to focus. So what I'm going to do now is we're going to come over to the other screen here, and we will look at Focus Max. Now Focus Max is all connected up to the observatory already, and we will now run an autofocus routine. And up here in the log we can see what it's doing. So it's doing a single star focus. It knows the current focuser position of 20,000. There we go, it's taken the first image. It will now analyse that image, and some stuff should appear here. We know there's a good star right at the centre of the field of view. I'm not getting any other charts showing at the moment. Come on, Focus Max. Okay, so the charts aren't showing correctly, but it is looking for the brightest stars in the image. I don't know why it took so long to basically do nothing there. So over on the other screen we can see the image that it took, which our bright star is right there in the middle. I can't believe how well centered on the crosshairs that star is. That is amazing. That's precision pointing for you right there. Okay, alright, so Focus Max has woken up. So here we are, the red dot here represents our star right in the centre of the chip. And okay, so this is a cross section to the star, showing a beautiful Gaussian distribution of pixels. And the focuser is now doing what? It's moving the focuser to get a defocused image, and okay, so it's tried to move it to 12,000. It's moved in even though it said it was moving it out. That's weird. Right, so we've moved to position 20,759, which it thinks is the near focus position, and it's taking images, and we're getting a HFD of about 9, and at the bottom here is a graph of the average predicted best focus position. So each dot on this black curve is the predicted best focus position for the image it's just taken. The red line is the average of all these points, and it will keep doing this until 4 of these points are fairly close together, and that's called focus convergence. And we can see the convergence steps up here is 577, which is really close to good enough. and there we're within 355, so it's going to accept that as a good focus position. So our actual focus position was 35,650, and the focuser is now moving to that position and taking a check exposure to make sure it really is in focus. And let's see what Maxim thinks of that. So I'm often quite surprised at how different. So Focus Max thinks our FWHM is about 4.6. Maxim's currently reading 8, 7.69. So it's like these programs, they don't agree with each other, not even close. Okay, focus position final is 35,656. FWHM is 4.22, and autofocus successful and completed. So what we can do now, let's go into ACP. I'll just come out of that for a moment, and let's look at the Acp Web Interface, and I'm just going to do a single image of M57. So M57, get the coordinates, there we go, position angle 0, duration 60 seconds, luminance filter, binning 1. We will not autofocus because we've just focused. We will acquire the image. Okay, and the observatory should then get busy on that. And here's a reminder of the one we took last night, which was horrendous, although quite artsy. And okay, so that's in progress now. So now we'll go back into the observatory computer and see what's going on there. You can see that ACP is active by the little red light thingy twizzling around here. And oh, it's not dark enough. ACP doesn't like that. It's telling me that it's not dark enough until 2047 UTC, which is in 3 minutes. So we may wait for that. Wait until it's dark enough. 2047 UTC. It is currently 2045 UTC. Okay, we'll just sit here and wait for 2 minutes, I guess. I'm quite pleased to see that the cooler has managed to reach the target temperature of -35 with only 77% power. So the observatory must have cooled down real quick after we opened the shutter, which will probably mean the telescope's going to be undergoing some contraction at the moment, so this focus position will probably shift a bit over the next hour or two. Okay, looks like we're off. Yep. The telescope is moving. There we go. M57 is very nicely positioned at the moment. Okay, we're doing a pointing update, which should work very nicely. Exposure complete, plate solving. We should be the polar alignment could be better on the telescope, so I'm expecting this to be a little bit off in terms of pointing because it's moved a few degrees. And okay, so we found 298 image stars, we found 1,344 stars in the catalogue, solved 219 stars, matched, pointing error 11 arc minutes. Yeah, so we need to do some work on the polar alignment. And it re-slewed, it synchronized the telescope and re-slewed to the target, and it's now taking the image, so we can see the progress bar going up here. By the way, I'm not monitoring comments at the moment, so I can't see if I've got any viewers or whether anyone's commented. I'm just ploughing ahead and trying to get this done so I can get the observatory into automatic mode. I will check at the end of the, once things are working, I'll check then to see if there are any comments or whether anybody's watched the video at all. But otherwise, I'm just chuntering away to myself, getting things done. So we are done. We're downloading the image. ACP will plate solve the final image and put all the world coordinates into the FITS header and things like that. It's very, very nice the way it does that. Image finished. This hasn't updated yet. I'm waiting for the thumbnail to update. There it is. Okay, so still observing. We're still doing that final plate solution. There we go. Plate solve final image. Now we've found 1,785 image stars, which is nice. Only 715 catalogue stars, that's interesting. Okay, we matched 348 stars, and our pointing error is now less than half an arc minute. Observing run completed. Let's have a look at what we got. There we go. A bit more in focus than it was. Okay, now what we will do at this point is I'm going to log out from the observatory. So I am going to just arrange all these windows, bear with me. Using a piece of software called Display Fusion to do this, because I've got about a dozen windows open literally. So I can load a Windows position profile, then it shuffles all the windows for me, puts them where they should be across the 3 screens I'm looking at. Keeps everything tidy. But now I'm going to log out from the remote session. So here we are back locally, and I'm going to run a little script down here which starts the scheduler. So start ACP scheduler. We should see the menu on the left hand side here change when the scheduler starts, because that will attach itself to ACP. ACP will realise the scheduler is there, and it will adjust itself to reflect that. And now we have a disabled scheduler, and we can now click here to enable that. This will okay, the scheduler is now scheduling. It should immediately try to start up the observatory, and there's not so much for it to do because everything's already started up, but nevertheless it will go through the routine, and it will then probably immediately realise it needs to do an autofocus. And so we will immediately get a test of whether we can autofocus. Now the scheduler is a dispatch scheduler. It has a database of targets, and I might be able to show you that. Whether I can do so while it's scheduling is, I don't know, but yep, there we go. So we can see that we have a bunch of projects in the scheduler, and none of them are running at the moment. Okay, here we go. So we've got the STXL Color Messier Marathon. This is kind of like a placeholder project I keep with all the Messier objects in it, and anytime there's nothing better to do, it just basically falls back to this project and takes one of the Messier objects. So if we drill down into that a bit, we should be able to see what it's trying to image, or what it thinks it might want to image. And it looks like it's going to do M17. Okay, because that's the project that's currently running. So, with that in mind, okay, startup complete. And it's gone, as I thought, straight into an autofocus. So there's the observatory moving. This is all good. Scroll down a bit so that we can see the log output, because there's not much interesting going to happen at the top at this point. Just waiting for the telescope to think it's finished slewing. Also the update rate of the web interface is about once every 5 seconds, so it sometimes gets a little bit behind what's actually happening. Especially if Bob's blocked the UI thread again. Okay, here we go. It has located a focus star. It's now moving to that focus star. So, so it went to the target and then moved away from the target to a focus star, which seems a little bit inefficient, but I can see why it's done that way. Okay, taking an 8-second pointing exposure at high binning, and we don't see any of the images in the web interface, which is a shame. We only see final image results and guide stars. It'd be kind of nice to see every image as it's taken, but we don't get that. So, plate solving, 70 stars matched. Pointing error was 7.282 arc minutes. Syncing and re-slewing. Which looks like nothing's happening because it's a tiny slew. And Focus Max is now running its autofocus routine. So, hopefully, this will work now. The irony of autofocus is you have to be almost in focus for it to work. It just gets hopelessly confused if you're out of focus because it doesn't know where to point the telescope or what to do with anything. Okay, so it's taken an exposure and plucked the star out of that and taken a subframe exposure. Okay, beginning focus run. Okay. Now it takes a first image and then it moves the focuser to see whether the image the star gets bigger or smaller, and so it knows which side of focus it's on from measuring that change in size, change of apparent diameter of the star. And so it's currently. So where did we start? Okay, so it's. Right, so it's estimated the near focus position as being 28,454, and it's moved there, and it's looking to get an FWHM, or rather a half flux density of about 8, and it's getting 7.45, which is pretty close. So it will now take several samples, and from this, every time it takes an image, it will predict the best focus position based on training data that's been captured earlier. And if we just zoom out a bit so we can see the convergence steps has to be within 500. So basically it averages the predicted best focus position each time it tries, and when those averages converge within 500 steps of each other, then it considers that focus has been successful. So we've come to a final focus position of 37,825, and these seem like big numbers, 500 focus steps, but each step is 0.052 microns. It's a very high resolution focuser, so it's 200,000 steps end to end travel, and that's only about a centimetre of travel physically, so each step is actually imperceptibly small. That's interesting. We had an error there. Rings argument must be array of. So I don't know why we're getting that kind of error coming out of Focus Max, because it's its own data. Surely it knows what parameters it's passing itself. I don't know. Anyway, autofocus completed. Focus Max autofocus successful. Final focus position of 37,825. Now I would like to see that much closer to 100,000, so it's in the centre of the range of travel. But it's because the telescope's hot because of the weather. That 1 centimetre of travel on the focuser is only just enough for this telescope, which is a 20-year-old telescope. It's just made of aluminium, so aluminium has a pretty awful coefficient of expansion for a telescope, and so it does affect. My focus position changes significantly day to day, so unlike the one in the next door observatory, which pretty much you can put a fixed focus position on there and never change it, and it's fine, which is very nice. Now what's happening? Why is the telescope going there? M17. Oh, M17, okay. Now I think M17 is in Sagittarius, if I remember right. And so that's really low down to the horizon. Which for this observatory is... I'm actually quite surprised it can image that low down, but nevertheless it does seem to be able to. What's the altitude? Yeah, see, it's 22.49 degrees of altitude. Air mass 2.6, but it's working. Plate solved. Pointing error. 12 arc minutes. Reslewing to M17. Now, this should take a guided image this time, which is something we've not done yet tonight. So we should see. Let's just change the screen slightly. There we go. Okay, so the guide is starting now. So it takes a 5-second image on the guide camera and then measures the brightness and everything and works out a actual ideal exposure, which has come down to 2 seconds. And the signal to noise ratio is 6, which is good, so we should get a nice bright guide star with not much noise. And there it is. There's our guide star image. Now if I click that, we see the whole field, the whole guider field, and it's pretty horrible. But out of that, somehow it can produce a nice clean guider image. The spark lines that you can see coming up here now are the guide errors in X and Y. This is like a radar plot of X and Y superimposed, and guiding isn't brilliant on this scope. It has an adaptive optics unit which I can't use at the moment because there are bugs in Maxim and they're taking forever to release the next version. So I can't actually use my adaptive optics at the moment. So I hope that guiding will significantly improve once that becomes the case. This looks pretty horrendous, and it is, but it's within 2 pixels basically. So the error, minus 2.99 in Y, that's pretty horrible. But it is correcting. Yeah. I don't think the scope's very well balanced, so this does affect guiding. So I would expect this image to come out a little bit smeared to reflect the bad guiding. Oddly enough, if you take a lot of subframes and average them, it seems to tidy that up really nicely. But it kind of leaves you with bloated stars. So this is a 300-second or 5-minute exposure through the red filter, and if M17 is what I think it is, then it's mostly red, so we should get a good image. It'd be a monochrome image because the CCD camera only takes monochrome images, and in order to get colour you have to take an image through each of 3 filters, red, green and blue, and then you can take those monochrome colour planes and stack them in the imaging software and sort of tell it, oh, this is the red plane, this is the green plane, this is the blue plane, and the imaging software puts it all together into a colour image. Unlike, for example, a digital SLR, which takes a colour image in one go. But that's really doing the same thing. It's just it's got like thousands of tiny little colour filters built in front of the sensor. So it's using a different technique, but it's basically, in essence, doing the same thing, using colour filters onto a monochrome sensor and then combining the colours to produce a colour image. Okay, 10 seconds to go. I can't count, can I? 30 seconds to go. Okay, the image should be complete. It will be downloading and plate solving at this point. and we should surely see the thumbnail. And image finished. Acp will be plate solving the image. There we go. Oh, and there's our thumbnail. Okay, so 2,391 image stars, 1142 catalogue stars. I've limited the magnitude I can use from the catalogue just to keep things manageable, which is why it's finding less stars in the catalogue. There are actually a lot more stars in the catalogue, but I limit the magnitude that I allow it to use. So 420 stars matched, pointing error 0.588 arc minutes, and let's have a look. Okay, very nice. I think we are in focus as good as it can be, and the scheduler's taken over control of the observatory, so I think we just leave it to go at this point. It will now be doing a green filter for that image. That project just does RGB images of all the Messier objects. So yeah, there we go now, it's doing the green filter. And so I will be able to, hopefully we'll get the red, the green and the blue, and I'll be able to colour combine that and post it up on the Facebook group in the morning. And with that, I think I'm going to sign off at this point, because the focus is now working again, the observatory is operational, and we just need to leave it be and see what images it produces in the morning. I've been Tim from Tim Tech Systems.